Hi students, we're going to do a work solution for the combination circuits party pack. So this one here should not really be attempted until you've done the set questions in Pearson, but let's see how we go. So in the first problem, what you've got is a parallel section here, and that is in series with resistor 1. So the first question is a pretty straightforward one. It's asking for the equivalent resistance of that circuit. So because I've got these two parts in series, I'm just going to add them together. So the resistance is going to be equal to R1 plus, and the part that's in series is actually in parallel, so it'll be the reciprocal of the addition of the reciprocals, like so. And if you put the values in, what you should get is 10 ohms plus which should end up being 10 plus 8.57. So your final answer should be 18.6 ohms. The second question is asking, what is the current flowing through R1? I know that the current that's flowing through R1 is actually going to be equal to the current flowing through the entire circuit, because R1 is in line with the current coming out of the battery, right? So if that's the case, that means that it's the voltage that's going into the whole circuit divided by the resistance of the whole circuit, which is the 18.6. So what you should get is 12 volts divided by the 18.6 ohms, and the answer should come out to 0.646 amps. And the next part of the question is now asking us, what is the potential difference across R1? So now that we know the current that's going through R1, and we know the resistance of R1, it's a pretty straightforward one. So it's just V equals IR. So it's going to be equal to the current, which is 0.646, times the resistance, which is 10 ohms, and we don't need a calculator for it. And that should just be equal to 6.46 volts. And the last question for this section, what is the current going through and the potential difference across resistor 3? So if we take a look at resistor 3, we can see that it's in parallel with R2, but we know what the resistance across R1 is. So what we want to do is we want to find out what the potential difference is between here and here, because the potential difference between there and there is the same as the potential between here and here. It's going to be the equivalent. Because they're in parallel, they'll have the same potential difference. So knowing that R1 is taking up 6.46 volts, that would mean that R2 and R3, both of them, so let's just do R3, oops, sorry, the voltage is going to be equal to the total battery power voltage, which is 12 volts, subtract the 6.46 volts, and you should get 5.54 volts. And now that you know the voltage across R3, you know the resistance is 20 ohms. So then you can say that the current across that would now be the voltage divided by the resistance. So it would be 5.54 divided by the 20 ohms. And therefore that'll be 0.277 amps. Alright, so for question 2, I've been given the values for R1, R2, and R3. I haven't been given the value for R4, but what I have been given is the voltage, which is 3.5 volts, and I'll just write that there so I know. And I've also been given the current going through there, which is 0.2 amps. From here, I can actually work out the resistance, but I don't necessarily need to yet, so I'm going to hold off on that. I might not need to at all. One thing I can identify is that if the current going through R4 is 0.2 amps, then that means the current going through R2 is also 0.2 amps, because they are in series with each other. So it's asking for the current through R3, but to start that, I need to find out what the potential difference is across R3. I don't know what that is, but I think I should be able to find out what the potential difference is across R3, because that's the same as asking what is the potential difference between R2, from basically R2 and R4, because they are the equivalent. So because R3 is in parallel with R2 and R4, then if I find out the potential difference across R2 and R4 combined, then that will be the potential difference of R3. And so I've got that this R4 has a potential difference of 3.5 volts, and R2 I know has a resistance of 50 ohms because that's given to me, and the current is 0.2 amps, which means that the potential difference for R2 is going to be 10 volts, so 50 times 0.2, and the potential difference for R3, which has already been given to you, is 3.5 volts. Now this is important because what we can do now is we can say, okay, well, the voltage across R3 is going to be the same as 10 volts plus 3.5 volts. So it should be 13.5 volts. Now that I know the voltage across there, I can work out the current by saying I is equal to V divided by R, and then we'll have our answer. And part B is asking, what is the EMF supplied by E1? Now I know that the total potential across E1, or what the battery is providing, should be equal to whatever the potential across R1 is, plus the potential across R3. So I know that the current going through R3 is 0.27 amps, which is a good starting point. And I just need to know what the current is going through the R2, R4 branch now. So to find that out, I can just... I don't need to worry about it. It's been given to me as 0.2 amps. So what's going through this branch is 0.2 amps, and what's going through this branch is 0.27 amps, which means the current going through the whole circuit is going to be 0.2 plus 0.27, and that will be equal to 0.47 amps. And that is the current that's leaving the battery and coming back to the battery, which also means that's the amount of current going through resistor 1. So I can write that up here if I want, 0.47 amps. And now that I know that I've got the current here and I know the resistance is 100 ohms, I can work out the potential difference across R1. So the potential difference across R1 can be calculated by saying, okay, the voltage is equal to IR. Total voltage, rather than do the total, I'll just say the voltage across 1 is the current through 1 multiplied by the resistance times 1. So it's going to be 0.47 times 100, which is the resistance, and you will get 47 volts. So that's the voltage across this resistor here. The voltage across here plus the voltage across R3 is going to be equal to the total voltage, which means that the total voltage is going to be 47 volts plus 13.5 volts, and you should therefore get 60.5 volts. Okay, so question 3 is asking us what the current is flowing through this resistor here, which is R4. Now it's given us the resistance of all the resistors, and it's also given us the voltage of the power supply. If it's given us the voltage of the power supply and the resistance through all the resistors, then right now I can create an equivalent resistor, one equivalent resistor, and then once I've got that, I can work out the current coming out of here. And if I could do that, that'll be a really good starting point, right? So the first thing I'll do is combine R2 and R4, and that would be 1000 plus what is it, 2500, which is equal to 3500. Better yet, I'll go one step further, and I want to combine that branch now in parallel with R3. So I'll just fix my writing. R3 plus, or not plus, in parallel with 2 and 4. So that's going to be the reciprocal of these two added. And what you should get from there is 947.9, sorry. So right now what I've effectively got is R1 and then an equivalent for the rest for these three over here. But now I'm going to combine it with R1. So the total resistance, because I'm going to combine all of them, is therefore going to be equal to the 200 ohms, 2000 ohms plus the 947.9, and that'll give me 2947.9 ohms. So what this represents is the resistance of the entire circuit. So now that I know the resistance of the entire circuit, and I know the battery power, the power supply to the whole circuit, I can figure out what the current is through the whole circuit. And that should give me 8.14 times 10 to the negative 3 amps. So not too much current. Now, and this is it. So now that I know the amount of current going through this entire circuit, I can figure out what the potential difference is just across R1, because the current going through there is 8.14 milliamps, and I know the resistance is 2 kilo ohms, right? So now that I've got that, I can say that the voltage across R1 is equal to the 2000 ohms multiplied by the 8.14 times 10 to the negative 3. So the potential across that particular point is 16.28 volts. So I've got, oops, not 16.28 volts. So over here, I've now got the potential across R1, and the only thing that's in series with R1 is this whole colophal here, and I could just say, well, if I know the voltage here is the 16.28 volts, that would mean that R3 would receive the rest of it. So you got 24 volts over here, and 16.28 volts is over there, which means R3 or V3 is going to be equal to the 24, subtract that, and you should get 7.717 volts. Now, I'm just going to point out, if this was designated A and this was designated B, the potential difference between A and B, we've just figured out, is 7.717, and this branch is in parallel with branch A and C. So the potential between A and C is going to be the same as the potential between A and B. So remember, the voltage across A and B, which is the 7.717, that is the same as the voltage across R2 and R4 combined. But what we need to figure out now is what is the current going through between A and C. So I can't really, there might be other ways I can figure this out right now, but all I can immediately think about doing is, well, if I know the current going into A is going to be the 8.14 times 10 to the negative 3 amps, I should actually figure out what the current is going through R3, since I know the potential difference. So I'll come down here and I'll say, okay, well, that means that the current going through the resistor number 3 is going to be V divided by R of 3. So I know the voltage, which is 7.717, and I know the resistance, which is the 1300. So now that I know that, I know the current going through there is 5.936 times 10 to the negative 3 amps. Great, so I've got that, and that would mean that what's left over from the 8.14 milliamps is going to be going through this channel here. So the current comes into point A and then it gets divided. Some of it goes to B down here, and the rest of it comes around through C before returning at B. So all I need to do now is say, well, that would mean that the current through 4 is now that will be the same as the current through 2, by the way, just to point out, and that's going to be equal to the total current minus the current going through number 3, which is, so it'll be 8.14 times 10 to the negative 3, subtract 5.936 times 10 to the negative 3, and I end up with 2.2 times 10 to the negative 3 amps. And you can just write that, if you want, as 220 milliamps. Alright, so question 4 is a little bit like question 3. You've got all the resistors and you know that the potential that's provided by the power source is 15 volts. So you want to basically get this pack of resistors down to one equivalent resistor. What seems to confuse people most of the time with this one is that they see this pack of resistors, here, and they panic a little bit. But this can be sort of seen as sort of R3 sort of joins R2 in parallel like this, and then R5 sort of joins R4 like that. So what we've actually got is two pairs of parallel resistors that are in series with each other. So what I'll do is I'll sort of break it down slowly here. You might be able to do it in less steps. So first I'll work out what R23 is. So that's going to be equal to the reciprocal of 1 on 10 plus 1 on 50, I think it is. And what you should end up with is 8.333 ohms. So that's this portion here at the top, and then I'm going to do R5 and R4. And I get 1 over 1 on 100 plus 1 on 5. And what you should get is 4.762 ohms. So now that I've got that bit sorted, I can now put it in series with each other and in series with R1. So that would mean that, so I could sort of start by saying, well, let's just worry about R2, 3, 4, and 5, and I'll end up getting just those two added together, and I get 13.09 ohms. So once I've got that 13.09 ohms, what that means is I can effectively forget about all of this, because there's nothing in the question that wants me to figure out anything about this, right? So instead, I can treat that as just having one single resistor coming down here, which is 13.09 ohms. 09. So that would mean that the R total resistance is going to be 13.09 plus R1, which is 25 ohms, and that's equal to 38.09 ohms. Okay, so now that I've got the total resistance, I can work out the total current, and that's going to be your V on R. So that's going to be 15 volts divided by 38.09. And what you should get is 0.394 amps. And now that we know the current going through the entire circuit, that's the same as the current going through R1. So therefore, the potential across R1 is going to be equal to IR, which is 0.394 multiplied by 25. So there's a few different ways that you can do part 5, but the first thing I'm going to do is I'm going to see what I've been given and make sure it's already in the table. So I know that there's a current going through R2, which is 2 amps, and that's there, but that also means that there's a current here of 2 amps, right? So that means here is 2 amps. I don't know the current going through R4 at this point. I know that since there's 0.5 amps going through R5, that means there must be 0.5 amps going through resistor 6. And here's the thing though, now that I know that there's 4 amps coming through here, right? There's 4 amps coming through there, and there's 2 amps here, and there's 0.5 amps there. That would mean that there'll be a leftover amount of about 1.5 amps, right? So that means I4, just do this properly, that will be equal to 4 amps, subtract the 2 amps going through one of the first branch, subtract the 0.5 going through the bottom branch, and then I end up with 1.5 amps, right? So I can say that's 1.5 amps. Okay, so looking at the voltages now, I can see that the potential across the battery is 9 volts, and I've been told that the potential across V5 and R5 and R6 have 5 and 1 volts respectively. So this is 5 volts here, and this is 1 volt here. That means that between this point here and this point here, the potential is 6 volts. That means there's a remainder here on R1 of 3 volts. So over here, that means that V1 would have to be 3 volts. V3 has to be, since the V2 is 3 volts, that means that the V3 has to take up the rest, right? So R2 is 3 volts, so that means R3 has to be 3 volts, so the total is 6. Oops. R4 is by itself, which means it has to take up the 6 itself. And the ammeter reading is, well, that current there is the same as the current going through R1, so it'll be 4 amps. Okay, so for question 6, we're looking at what is the current going through here, and what is the potential between A and B. Since we've been given the values of all the resistors, this is a classic one where you just need to figure out what the equivalent resistance is, but it's a big one, right? So let's start from the left and go to the right. So the total resistance is going to be equal to that 4 ohm resistor plus the 3 ohm resistor plus 1 divided by 1 on 3 plus 1 on 3. But since these are the same, you might have already identified that this whole thing will come to 1.5 because the resistance will halve. And plus the 7 plus, and this one here is the reciprocal of 1 on 20 plus 1 on 4 plus 1 on 10. And plus that 6 ohm resistor at the end. Now when you break this down, what you should end up getting, I've done this earlier, is 4 plus 3 plus 1.5 plus 7 plus 2.5 plus 6, and that will equal 24 ohms. Now since the power source is also 24 ohms, that would mean that the current going through the entire circuit would be the 24 divided by 24, which would equal 1 amp. And the voltage is going to be IR, right? So the voltage across that one resistor between A and B would be IR. So it'll be the current going through it, which is your 1 amp, multiplied by the resistance, which is 4 ohms. So I guess you can just say 1 times 4, so it'll be 4 volts. Okay, question 7's got this circuit, and it's asking how should the switches be arranged for there to be the least amount of current measured. So for that to happen, we need to have the most resistance, which means we only want to have switch 3 turned on. So when switch 3 gets turned on, that means the current will effectively only go through one of these resistors. So that means switch 3 should be on and the other 2 should be off. And if that's the case, what you'll have is a total resistance of 420 ohms. And that means I equals V on R. So it was 36 volts, so it'll be 36 over 420. And you should end up with a number like 0.0857 amps. Now for part 2, it's asking how should the switches be arranged to have the maximum amount of current. So to maximize the current, I want to flatten this switch and flatten this switch and flatten this switch, so that the current comes through here and then splits into 3, or it allows 3 different pathways for the electricity to flow. So I want to turn them all on. And the total resistance will therefore be the parallel of those 3. So it's going to be 1 over 850 plus 1 over 420 plus 1 over 680. And that will equal 199 ohms. So the current will be 36 over the 199, which will be equal to, if I've done this correctly, 0.181 amps. And finally, question 8. It's one that can be solved a number of different ways, but I'm going to use this as an opportunity to show you how you can do it effectively just using ratios. So you could find the current going through different parts of the circuit and then solve for it and find the potential difference. But what you need to find out is what is the potential difference across from here to here, and what is the potential difference across from here to here. Now you know that if you went from one side to the other, you should get 19 volts. Now, the important thing is, when you're finding the potential difference between A and B, there's a voltmeter between them, so no current is going between them. There's no circuit there. It's just going to be probing what the potential difference is. And this is where the idea of potential difference actually really comes through. So if we treat the negative end of the battery as ground, so we can see that the potential will grow the further away you get from that negative terminal. So what you need to do is find out what is the potential for current to flow from point A down to ground, and then what is the potential for current to flow from point B to ground, and then to determine what is the potential difference between the two, or literally what is the difference. So it looks pretty complicated, but it's actually a very straightforward question. First thing I'm going to do is I'm going to find out what is the potential difference at that point there. I think I'm using the wrong pen. So now I'm going to use ratios. So I know that between the 130 and the 150 ohm resistor, there is a potential of 19 volts, right? And I also know that the amount of voltage that each resistor soaks up, or how much voltage it takes up, depends on its resistance. We know that V equals IR, so we know that the voltage is proportional to the resistance. So what that means is, if I find out what the total resistance is between these two, and find out what portion of that this resistor takes up, that's the same portion of the voltage that it's going to accompany as well. So to sort of write that mathematically, I can say that the voltage for the 150 ohm resistor is going to be equal to the ratio of how much the 150 ohm resistor takes up over 130 plus the 150, okay, multiplied by the total voltage, the 19. So effectively what you end up with is 10.18 volts. So you can see that's a little bit more than half of that 19 volts, which makes sense because it's a little bit more than half of the total resistance. So then I do the same thing for the 110 ohm resistor. So up here it's 110 ohm resistor. What portion is this taking up of the whole thing? So I've got 180 plus 110, so I know that's 290. And I multiply that by the total potential that those two will have, 19, and I'll get a number of 7.207, 7 volts. And this can be done in any circuit. If you know the relative resistances, you can figure out sort of the portion of the potential that they'll take up. So now that I know the potential between ground and A and the ground and B, because I know the potential across each of these resistors, all this voltmeter in the middle is going to be recording is the potential difference, or the difference between these two values, which means that the potential between A and B is going to be equal to 10.18 subtract 7.207, which would be equal to 2.97 volts. But of course, if you solve this by first figuring out the current going through these resistors and then working out the voltage that way, then you should get the exact same answer. There's no issues there. And that's the combination party pack solutions. Thanks.